based on all the people that have signed on, so thanks for being on time. Ryan, is my sound still good there in Walnut Creek?
Yep, you sound good.
Okay, great. Then let's get started so that we don't take any longer than we need to. Thanks everybody for joining us today. Ryan, I think you're going to record this, right?
It is recording.
Okay, excellent. Perfect. Well, thanks for joining us for this BikePed201 webinar on design standards and guidance for bikeways. This is a webinar put on between both the Bike and Ped Discipline Group and the Engineering Discipline Group. A little bit of history on why we're doing this. The BikePed Discipline Group, a couple members, Ryan included, and Megan Mittman, deliver Bike and Ped 101 through the Fair and Peers Academy course lineup. And through that course, we'd heard that there was kind of a desire for a little bit more detail on design specifically for bicyclists and pedestrian infrastructure. So we heard that feedback. We also took a survey of BikePed Discipline Group members last year of different webinars that they thought would be valuable for the company in 2015, and this ranked very highly in that survey. So today we're scheduled to go for 90 minutes until 1 o'clock Pacific on the West Coast. Ryan and I have kind of oriented this to hopefully only speak for about 60 minutes and leave the last 30 minutes for Q&A. One of the things that we kind of decided yesterday when we were looking through this for the last time, we were wondering if we got the right level of detail here, and we both thought, wow, we could teach this course for a whole day. How do we do it in an hour? So we decided that really the most valuable thing to do was leave that 30 minutes at the end for Q&A and hopefully have as much dialogue as possible and hear what questions people from around the company have. So with that, I'll just do a couple introductions. I'll let Ryan introduce himself here in a minute. If I haven't met you before, my name is Charlie Alexander. I've been with Fair and Peers for almost 8 years now. I'm in the Denver office. I've been here for a little over a year, and I spent my first 7 years with the company in the Roseville office. I'm a registered civil engineer in several of the states where we work, as well as a certified planner. This year I started leading the Bike and Pedestrian Discipline Group after being a member of that group pretty much as long as I've been here. I also instruct on Complete Streets through two different organizations. One, the National Complete Streets Coalition, and also a course that a few of us Fair and Peers employees teach through UC Berkeley Tech Transfer. I've also implemented and designed several innovative bikeways, predominantly in Northern California when I was in the Roseville office, many of which were at UC Davis through on-call work that we did there, helping serve the demand of the 47% of students that use a bike every day to get to class.
All right, and as Charlie said, my name is Ryan McLean. I've been with Fair and Peers about 7 years. Before that, I worked in more general civil transportation design, so a lot of my background was in detailed design of everything from freeways down to intersections. So I brought over a lot of that design emphasis when I came to Fair and Peers. I'm a registered civil and traffic engineer in California. And as Charlie mentioned, I'm involved in both the design and bicycle and pedestrian discipline groups and do a lot of work between the two and act kind of as a liaison between the two. I've done a lot of work all the way from the planning stages up through final construction documents on innovative bicycle treatments, complete streets projects throughout the Bay Area and elsewhere in Northern California as well. So kind of that emphasis from all the beginning of the planning stages all the way through a completed construction project is what I like to do.
Great, thanks Ryan. So with that, we'll dive into the content here. And let's talk first about why this is an important topic. I know a lot of us have been hearing about design standards and guidance for bikeways shifting over the past several years. A lot of that is because we've been trying to design more towards the interested but concerned bicyclist types instead of the strong and fearless. There's been a general sense over the past decades that the infrastructure we were designing really wasn't doing much to get more people riding their bikes and not really attracting that majority of the population, the near 60% that define themselves as interested but concerned. Bikeway design is really something that's constantly evolving. I'll talk about that a little bit later, but a lot of the forms of guidance that we're using now are updated pretty much on an ongoing basis. So we can't just rely on the book that's been out there for 5 years. We really have to be constantly monitoring it and staying updated if we're going to give good advice to our clients. And part of that evolution is that the number and types of forms of guidance has been increasing as well. So just staying on top of all the books that are published and making sure we know what they are and what their limitations are is certainly a challenge, and it's something that Ryan and I spend a lot of time on. And ultimately, what's important about this is that we provide our clients with really the latest and best advice. A lot of that is to make sure that whatever gets built operates safely and comfortably and efficiently. But also it's important that we do that to stay at the leading edge of the market. So I think hopefully everybody will take away a lot from this presentation that makes sure that we're doing all those things as we move through the design process. With that, I think it's over to Ryan.
All right, thanks, Charlie. So did want to start out by talking about what is the design process and how do we go from something that's proposed in, say, a master plan or a specific plan that really starts out at a very high level. How does that actually get put onto the ground? And so, as I said, you start out, with a proposed project that doesn't have a lot of detail, but the general concept is understood in say, a bicycle master plan, a general plan. But then that needs to be taken to the next level and really look at some more of the details and start figuring out what that means. And that's really where we talk about the conceptual design. And these days, a lot of times we'll include some conceptual designs in our master plans. The idea is that we make these more implementable and more focused on projects that can be put into place. And the concept plan is usually defined by an Illustrator type graphic as opposed to, say, an AutoCAD drawing. So it's a higher level. It's not necessarily to scale. It's done over the top of an aerial. But it does start to get into more of the details than are just outlined in the broader plan. And then the major elements are decided in this phase. You'll usually see cross sections identified, and then some of the intersection treatments are started to be looked at. But then to take that to the next step, we get into the stage that's known as 30% design, 35% design, 25%. A lot of different numbers are thrown around. But what that really means is that we're taking it out of Illustrator and putting it into AutoCAD and actually doing a scaled drawing, looking at how that works from the major design elements and actually starting to vet some of these features. It's also when we start to get into more detailed cost estimate and can be really used to plug into grant applications at that stage. It used to be that you could do grant applications really off of a concept design, but more and more they're looking at more details when you get into the grant applications as well. So that's where we really see 30% design. And often if we know we're going to go to that level, we'll either do the concept design in CAD or almost combine the two to move that forward. From there, it would go into more of what were considered the construction documents, and I'll talk a little bit more about those, and then that goes out to final bid and construction. So in theory, I have control. We'll see if it moves forward. Okay, so this is just, again, an example of the concept design. You can see the illustration here. This is from a project on Telegraph Avenue in Oakland that we took all the way from really the planning stages through to construction documents. So here it's really just an Illustrator document. You've got some of the cross-section elements called out, so you know how wide this thing is going to be and know that it will fit within the curbs. But otherwise, it's pretty general, very illustrative of the concept that you're trying to convey to the public. That's important, is that these graphics communicate that to the public. At this stage, you might include things like the bike boxes, and we'll get into all these details later, showing crosswalks, and it's somewhat vetted in terms of, is this going to work, but really not to the level that you need to for the concept design, or excuse me, the 30% design. So 30% design is really when we pull it into AutoCAD and start to scale everything off, do all the tests that we need to make sure this is going to work, really start to ground truth this and make sure that everything can be accommodated where we think it can. It's when we start to get into a higher level review with the agency and make sure that they're comfortable with all the things that are being proposed. Really start to look at conflicts that could be existing. So this is when you start to look at, is your curb ramp that you've proposed actually going to fit where you are saying that it should? And again, this is where you swap out from more of a figure type title block that gets stuck into a report to more of a construction document type title block that you'd see in a set of plans. From there, it would go into the construction documents, and there's usually several phases of this. Those are usually defined by the percentage, 65, 95, 100 final percent plans, and the package is usually, you'll hear the term PS&E, and that stands for plans, specifications, and cost estimate. And the plans are obviously the what is supposed to be built. That's what most people are familiar with. The specifications are how that gets built, and it's really kind of the contract with the contractor, saying that you're going to build these things to this level, you're going to get paid in this manner by the square foot for sidewalk, by the linear foot for curb and gutter. That's all defined in the specifications. And then the cost estimate is obviously how much the engineer is estimating that this is going to cost. And that gets turned over to the contractor, and the contractor bids on those specific items, and hopefully you're pretty close in your cost estimate. And then, so that happens at the 100% or final design stage. A lot of these names change. Sometimes there's 3 final sets of plans, depending on when the agency starts to actually review it. And then once the project is completed, we get to the as-built, and that's basically a record of anything that was changed in the field once they built it, and then that's the final record drawings that the city stores and can be referred to later down the road if you want to change or update the project.
Great, thanks, Ryan. So I think I can control it from here, even if you still keep control as well. So, okay, so what's the difference between standards and guidance? Oftentimes those two words are used really interchangeably, but in fact, in the engineering world, there's actually a very different weight to each of those words, and that means that we have to use them very carefully. So a very general way of describing this is that standards are things that really must be followed, and you have to document it, and you cannot follow that standard. So we'll talk a little bit about the idea of what a design exception here is in a minute, but that's something that we often hear, especially when working with state DOTs like Caltrans. Guidance is a lot different. Guidance inherently has some varying degree of flexibility in it. Guidance is information that might not apply in all situations, but it's there to guide you when the situation is relevant. And usually you don't have to require, or you don't have to document exceptions to guidance, because it's guidance. You didn't have to follow it. You just chose not to. So obviously that depends from jurisdiction to jurisdiction, but generally less strict than standards. So a really simplified example of this is the way that the Manual on Uniform Traffic Control Devices, the MUTCD, describes stop signs. So the MUTCD is very prescriptive in its language of what is the standard versus what is guidance. So for example, in the MUTCD, a stop sign shall be octagonal, shall have a white legend, shall be red. All of those very straightforward things that if we didn't do those things, it's very likely that the design would not function safely or as intended if the stop sign was green and round, for example. The MUTCD has some guidance, however, that allows you to use specific plaques with different messages, like traffic from left or right does not stop, or oncoming traffic does not stop, that you should use those at certain intersections when there are certain conditions that make it relevant to do so. So that's the case of something that's a standard versus something that's guidance, something that you have to follow versus something that inherently has a little bit more flexibility built into it. So when we talk about standards, what constitutes what is a standard versus what is guidance? There's really two ways of making something a standard. There's standards that have legal standing. So typically the ones that we see that have legal standing are the standards for traffic control devices. So this would be the Manual on Uniform Traffic Control Devices, the MUTCD. This is actually referenced in California Vehicle Code. CVC section 21400 requires that Caltrans develop uniform standards and specifications for all official traffic control devices. CCD. And then Vehicle Code 21401 specifies that only the standards developed by the Department of Transportation by Caltrans shall be placed on a street or highway by all the jurisdictions in the state. So that's requiring all the cities, counties in California to use the MUTCD. It turns out that all of the states where we have offices have similar legislation referencing an MUTCD. Colorado in their revised statutes, Utah in their revised code, Utah in their code, revised code in Washington, and then Washington, D.C. has this in their municipal regulations. So that's the first way that something can become a standard. The second way is how geometric standards often come to be standards instead of guidance, and that's that they become adopted by a jurisdiction. So in California, Caltrans adopts the Highway Design Manual as their standard on the state highway system. Generally, off of the state highway system, the Highway Design Manual is guidance, not standard, but on the state highway system, because it's adopted, it is standard. And then various cities and counties have their own standards or design and procedures manuals. So the Sacramento Design and Procedures Manuals, this is something adopted by Sacramento City Council as their standard. And then City and County of Denver here in Colorado has their transportation standards and details. Those are adopted by City Council. Most major cities have something like this that we're often dealing with when we're designing infrastructure. Guidance is a little bit different. There's many different forms of guidance, and usually these don't have any standing as having been adopted by a city or by an agency. They're just out there, and we use them primarily to make sure that we develop designs that are safe, that function well, that are efficient, and also to shield ourselves from liability, because if we're using design guidance when we develop standards, it's much more safe when we get, if there were to be a civil suit on that facility, we can say, well, we've followed this form of guidance when we designed this, therefore we don't think that this claim has a reasonable basis. So Ryan and I kind of described these in three different forms, kind of the first being the mainstream traditional forms of guidance. This would be things published by AASHTO, the American Association of State Highway Transportation Officials, either their policy on geometric design of highways and streets, the Green Book, or what we call the Bike Guide, which is their guide for the development of bicycle facilities. Off of the state highway system in California, we would typically call the Caltrans Highway Design Manual a mainstream traditional form of geometric design guidance. Then there's kind of this mainstream innovative category. This would be anything published by NACDO, National Association of City Transportation Officials, either their Urban Bikeway Design Guide or their Urban Street Design Guide. This is also where we would categorize the CRO Design Manual for Bicycle Traffic. CRO is a Dutch nonprofit, which is kind of a quasi-governmental organization that publishes the various design manuals for transportation and infrastructure used in the Netherlands. I think CRO is an acronym, but I'm not actually sure what it means, but that would fall within the mainstream innovative category. And then there's several other recommended practices that we won't go through here that could also be used as forms of guidance. So these are the two standards that, at least in California, we're most accustomed to seeing. Other states we're certainly accustomed to seeing the MUTCD as well. On the left being the Manual on Uniform Traffic Control Devices. There's a few different ways that this is developed and then implemented in the different states. Some states take the version that's published by FHWA and adopt it in its entirety. So Hawaii is an example of a state that does that. Some states take the FHWA MUTCD and then add a state supplement onto it and then adopt that version. That's what we do here in Colorado. That's what they do in DC and in Washington. And then some states actually take the FHWA MUTCD, do a kind of thorough editing and redline job on it, and then adopt that as a state MUTCD. So that would be the California MUTCD or the Utah MUTCD. These are those various different forms of guidance that I described earlier. I think I talked about all of them with the exception of the two on the top right, and those are the FHWA Separated Bike Lane Planning and Design Guide. This is something that I think just came out earlier in 2015, maybe just a few months ago. And then the ITE Recommended Practice, Recommended Design Guidance to Accommodate Pedestrians and Bicyclists at Interchanges. This is something that Megan Mittman and Matthew Ridgway and Mike Johnstone worked on a lot over the past few years. So these are all things that those of us in the BikePed201 group and doing bikeway design, we're constantly referring to all of these forms of standards and guidance when we're doing design. If I had to assign a hierarchy that's typically observed in our industry and by our clients for all these forms of design standards and guidance, it would probably look like this. In that first box at the top are things that are standards, so the MUTCD would always be in this box. Sometimes other forms of guidance would be included if they're adopted by the local agency. So for example, the Highway Design Manual on the California State Highway System or other locally adopted policy and procedure manuals. In some cases, cities have actually adopted either the NACDO Urban Street Design Guide or the Urban Bikeway Design Guide as their standards. It's a little bit unusual, and I'll talk a little bit more about that in a minute. In the second box are what I would call mainstream traditional geometric guidance forms that we typically see, so either the AASHTO Green Book or the AASHTO Bike Guide. And then in the number 3 position are the various mainstream innovative forms of guidance, the various ITE recommended practices, the NACDO guides typically, the CROW would be here, as with the FHWA Separated Bike Lane Planning and Design Guide. And then all the way in the bottom are all the other less mainstream forms of guidance, such as various informational reports published either by ITE or FHWA, or any random city's bikeway design guidelines that are included as an appendix to their bike master plan that you can find somewhere, but you have no idea how they were developed and whether or not they're really relevant to the context in which you're designing. So usually what happens when we're operating within this framework and within this hierarchy is that any time that we want to use something lower in the hierarchy as a form of guidance that's different from something higher in the hierarchy, we need to be able to communicate those differences to our clients and be able to make a good documented decision as to why we're doing that and why we're following kind of one of these lower forms of guidance instead of one of the more mainstream common forms of guidance. It's not necessarily a rule, it's just generally the way that we've done it in the industry, and it's really what our clients value is being able to bring this information about why we should use something from a NACDO guide instead of something from the AASHTO Green Book, for example. So flexibility in design is actually handled in many, many different ways. The MUTCD is pretty prescriptive in how it defines flexibility, and it uses very clear and specific language. So all the traffic control devices in the MUTCD have language of whether it's a standard and then they use kind of the you shall do this language versus whether it's guidance and you should do this, options, you may do this, and then support. So it's pretty easy to identify what you have to do versus what you should or may do in those situations. Geometric design is usually, the flexibility there is usually provided in the form of design exceptions. So in California, on the state highway system using the Highway Design Manual, there's a very formal process you have to go through if you're going to deviate from the Highway Design Manual. And that's certainly drawn the ire of many engineers over the years that oftentimes whether or not you need to pursue a design exception on the state highway system is reason either to or not to pursue a design. Off of the state highway system, the process of getting a design exception or filing a design exception is really less formal and depends on the jurisdiction. And really all they're looking for you to do in most cases is to document engineering decisions made. So provide a clear written record of why you've decided to do something different than the guidance typically recommends, so that if there ever was to be a civil suit, they could go back to the file, go back to the as-builts and say, oh, here's the record of why we decided to do this way. And hopefully that's what shields them in the court of law should there ever be an accident on the facility. So I mentioned that bikeway design was something that's constantly evolving, and the status of various devices in the MUTCD is a really good example of that. devices, traffic control devices can either be allowable, which means that they can be implemented with existing MUTCD standards and guidance as is. Sometimes devices might have interim approval, which means that they haven't yet made it into the MUTCD, but they've been approved by FHWA in the interim. They might be subject to experimentation. This is the process that's used to determine whether a device should receive interim approval and be included in the next iteration of the MUTCD. FHWA will issue official interpretations. This isn't really saying whether it's allowable or disallowable, but it's formal letters written by FHWA clarifying how the MUTCD should be interpreted. And then there's devices that are disallowed. So these are devices that just specifically have been disallowed by FHWA and by the MUTCD. So for many of the different types of bikeways that we're going to talk about today, FHWA constantly maintains this website. We've included the link at the bottom that tracks the MUTCD status of all the different various innovative bikeway devices that we'll be describing today. I mentioned that a lot of devices are subject to experimentation. FHWA and many state DOTs, including Caltrans, have official processes for experimentation and have committees that actually review those experiments to determine whether or not they've been successful. And this is really the formal process through which new devices can either be allowed or disallowed or included into the MUTCD. So in general, the process includes submitting a request to FHWA and possibly to your state DOT, including a statement discussing that need for the new device. FHWA and or your state DOT will review that request, and if permission is granted, you can install the device. Some of the important things that I always caution my clients on is that if you're going to experiment and request to experiment, they're going to require that you evaluate that experiment over a period of 1 year, and you actually have to provide a detailed evaluation plan in your application. So there's some effort involved in the experimentation process, and ultimately that evaluation is what informs whether or not it should be an allowable device in the future. And you also have to agree to restore the experimental site to a pre-existing condition if they find out that it doesn't work well and they don't want to allow it in the future. So that's generally how the process works. Usually experimenting with new devices is, some jurisdictions are really excited to do it. In most cases, jurisdictions have not wanted to do that because they don't want to incur the extra cost. That's my experience at least, but I know it's a little bit different depending on where you live and where you work. So some emerging trends in bikeway design that we wanted to talk a little bit about. The first in California is Assembly Bill 1193. Prior to this, there were only 3 types of bikeways officially recognized in the state of California. This created a 4th classification, Class 4 bikeways called cycle tracks, and also required Caltrans to develop design standards for them, and also lifted a previous requirement that jurisdictions only use the Highway Design Manual when designing bikeways off the state highway system. And getting rid of that requirement actually made it possible to get various innovative devices, some of the stuff that we see in NACTO, funded through state-specific funding sources like the Active Transportation Program. NACTO endorsements are something that we're seeing more and more frequently throughout the United States. Some of the states that we're working in have endorsed the NACTO guides officially, as well as many of the cities. There's really varying degrees of weight with these endorsements as to what they mean. I know Caltrans and the city of Denver here, they both endorse the guide, but they don't really know what that means, and they really still use their standard forms of standards and guidance. Whereas I think it's Modesto in California has actually adopted the NACTO guide as their standard, and they use it as such. I'd say that's a little more rare than kind of the ambiguous endorsements where they have to kind of reckon with the meaning. But it's good to know and ask those questions when you're working with clients in any of these cities. And then there's also Vision Zero. This is a movement that started in Sweden, which aims to achieve a highway system with 0 fatalities and 0 injuries. And kind of the evolution of bikeway design is really kind of consistent with this vision that what we're trying to do is design and implement a system that's safe for all users. And I think we'll see a lot more cities jumping on that bandwagon in the future.
All right, so now we're going to get into the details of what these facilities are and what really it means to do innovative bicycle facility design. So as Charlie said, this is a rapidly evolving field, and so we're just going to start off by talking about some of the traditional bicycle facilities. These are the ones that you see all over. They're in the traditional guidance. They've long been approved. So we'll go over those briefly, then get into more of the innovative treatments along the corridors, and then talk about the innovative intersection treatments that go along with those. So starting with shared use paths, which has long been called Class 1 bicycle facilities in Caltrans lingo. That's really when it's completely separated from the roadway. It's its own path. It can include a side path where it's running alongside a street, or it can include something like the Iron Horse Trail here that's its own separate path that crosses streets at different locations. So the minimum width as defined by the Highway Design Manual is 8 feet for a two-way, 10 foot is preferred, 5 feet for a one-way, and then 2-foot shoulder on either side. The other requirement is that if it's running alongside a roadway, that it is separated by 5 feet minimum. And this has actually caused a lot of trouble in terms of putting down side paths along streets with limited right-of-way, and getting that 5-foot separation is actually a difficult thing to do. And then it sometimes would have striping to differentiate areas for bicycles and pedestrians, but in general it's a mixed-use path, so you've got pedestrians interacting with bicycles, and this can also lead to congestion where you've got a lot of either of those. It also means that you need to meet ADA requirements, accessibility requirements. So in terms of slope and detectable surface, like you see the yellow dots, all need to be applied to shared use paths when you expect pedestrians to be using them. So that puts some limits on what you can do with those. And then the Class 2 by Caltrans is the standard bike lane. And this is often just the single stripe on the road that we've long seen, along with bike lane stencils designating that as the bike lane. The minimum is 5 feet with the gutter or 5 feet with on-street parking. Now this is the minimum. We don't recommend the minimum. We say at least 6 feet, especially when you're adjacent to on-street parking. It just becomes too tight of a space with the door zone, people opening their door into it. And then also a maximum is 7 to 8 feet, and that's really because once you get above that, it starts to look more like a vehicle lane, and you don't want vehicles driving down the bike lane. It also can lead to people parking in it, thinking that there's still enough space for bikes to sneak by if I park in a 9-foot bike lane. So that's why we have that maximum there. To address the door zone issue, different jurisdictions have tried different things. One of the most common ways is to use parking crosses instead of parking tees, and that's where you see the piece of the parking tee sticking out into the bike lane. It sticks out 2 feet in general, and that is a reminder that you need to ride away from that door area so that someone doesn't open the door into you. Now, 2 feet is not really a sufficient space, so again, that's why we push for the wider bike lanes to allow enough room there. Another way is to add that second stripe along the parking lane and really try to better define the difference between the parking area and the bike area. And then we get into what's known as Class 3 bike routes in California, and that's really just traditionally where you put up some signs that say bike routes. The green signs that just show wayfinding or that say bike route, but really nothing else. And the effectiveness of just putting up signs that say bike route in terms of motorists understanding that they need to be sharing the road with bicyclists is questionable. So along with the bike routes came the shared lane marking, and so then at least we got some sort of striping designation on that to remind motorists that this is also where bicyclists need to be or are allowed to be. But again, this is not for those interested but concerned riders. This is for the strong riders that are comfortable sharing a lane with traffic. It's often been used as a gap closure, the Sharrow designation there, but that's really a way to stress the interested but concerned riders out, is by dropping them from a nice bike lane into a shared lane with vehicles. But it's still often used for that. Our guidance, well, so the MUTCD says this needs to be placed 11 feet from the curb when you've got parking. So that basically puts you out of the door zone, questionably out of the door zone. More than 11 feet is always preferred. And really our guidance now is to put the Sharrow marking in the center of the lane, because there's not enough room for vehicles to pass a bicycle if it's pushed over to the side. So have the bicyclist take the entire lane. Motorists can pass when there's a second lane or if there's a passing area. So that's kind of how the Sharrow practice has evolved. It's also kind of goes along with the 3-foot law in California that just went into effect, where motorists have to give 3 feet clear to bicyclists to pass them. And so putting the bikes over to the side with a Sharrow kind of encourages motorists to try and stay in that one lane, and so it doesn't really support that 3 feet either. There's also the use of green-colored Sharrows, and there's a couple examples here. The one on the left is a continuous green space, and with Sharrows placed intermittently along there. This is under experimentation in several locations, including Oakland, which we've been involved. Carrie Nielsen has been extensively involved in the experimentation process with this. But no more experiments are being allowed under this. And it's looking like it doesn't make a huge difference between just a greenback Sharrow. But then the greenback Sharrow is still allowed under experimentation. And it really emphasizes that Sharrow, really brings it out. It's good when transitioning from a bike lane to a shared lane, that situation we're trying to avoid, but it really helps make that a higher emphasis. Also, where there's higher vehicle volume, it is a good indicator. And again, the second benefit of Sharrows is they can provide guidance when bike routes, say, change from one street to another, make the turn. So it's really good to give that guidance. Here you can see it's shown in a left turn lane. The bike route is turning left. So it's a good indicator that that is what is happening there. So another, an innovative treatment that is kind of building off of the shared roadway treatment is the bike boulevards. And really the idea behind bike boulevards is that you're choosing streets that don't have a high vehicle volume, they don't have a high vehicle speeds, that are more comfortable for a general use bike facility. And they can be accompanied by the large stencil you see on the left. That's in Berkeley, really takes up the entire roadway. Or some jurisdictions like Palo Alto just like to stick with the standard Sharrow. And the bike boulevards, it's really a combination of wayfinding, traffic calming, volume management, crossing treatments, traffic control adjustments, which I'll get into, and route planning, all kind of combine to get the traffic volumes and the traffic speeds down to where they should be and make it more comfortable for bicyclists. So some rules of thumb for bike boulevards: you want to have average daily traffic volume of less than 3,000 vehicles. You want to have the 85th percentile speed, which is what we usually use to set speed limits. It's a good measure of the general speed on the roadway, of less than 25 miles per hour. And so you can accomplish both of those things by implementation of traffic calming measures such as traffic circles, and medians and that sort of thing. Partial closures are often used to divert traffic away from that bike boulevard. Traffic control device orientation: you don't want a bunch of all-way stop signs or even two-way stop signs along your bicycle boulevard, because we all know how difficult it is to stop on a bike, come to a complete stop and start riding again, especially when there's no cars on the side street. So that's where flipping the stop signs to the other street is often a treatment, as well as the traffic circle or mini roundabout can be used. Those are great for allowing bikes to continuously move through the intersection. Now, flipping stop signs can often be controversial. People see stop signs as really a traffic calming measure on their street. So when you stop stopping traffic along their street, they see that vehicle speeds are going to go up. So you really need to accompany that with some sort of traffic calming measure, such as speed humps, to slow down that traffic that now won't stop. And then signs and markings, you really want to emphasize that this is the route that is designated for the bike boulevard. There's various standards for that sort of wayfinding signage. And then also pay special attention to the major street crossings and think about whether those should be signalized, whether they should have some sort of enhancement to indicate that bikes are crossing here. And then also, a lot of pushback comes from fire departments. They don't like to have a giant circle in the middle of their response route. They don't like tightening up of curbs when they're trying to make a turn onto streets. So it's really important to work with the fire department to come up with a solution that works. And a lot of that goes back to just demonstrating with the fire department, maybe using cones or something out there that they can make these things work. Another innovative treatment is the advisory bike lane. And this really allows you to, when you have higher volumes than the 3,000, this can be used in volumes of 4,000 to 6,000 to separate the bicycle and the vehicle traffic, but acknowledge that there's not enough width for cars to pass each other without going into that bike lane. So here you can see it's a solid line up against the parking, but then a dash line for the travel lane, and then you remove the center line. And so this is similar to appearance in the dedicated bike lanes, except for that dash stripe. And the idea here is that bicyclists are allowed in those lanes, but if a car approaches, then that car has to yield to the bikes, and then if they need to move around an opposing truck or vehicle, then they do that once the bike has passed. Here's the dimensions that we recommend. 5-foot minimum, 7-foot preferred for that bike lane. 14-foot minimum, 18-foot preferred for the vehicle travel lane. And if you think about the 14 feet, that's 7 feet in each direction. Cars are going to have trouble passing each other without crossing into that bike lane. 18-foot cars can get past each other pretty easily, but if a large truck came down the street, then the opposing traffic would have to go into the bike lane. And the example that I like to mention on this is on narrow residential streets where parking is allowed on both sides of the street, but really that means that two cars can't get past each other in that space that's left. Then one car will often pull over behind the parked car, allow the other car to pass, and then pull out and continue. So it would operate similar to that, except that there's space for bicyclists. The next one I want to talk about is the contraflow bike lane. And this is where you have a one-way street but want to allow bicyclists access to the opposite direction. And this is often used as a gap closure when there's not a direct route for bicyclists or an alternative route and you want to get them to the other side of that one-way street. It really just works similarly to a vehicle lane because you're just putting down a centerline stripe and allowing two-way bicycle traffic. You need to place do not enter signs along with bikes accepted, signage similar to that. It's not specifically addressed in the MUTCD, but it is in the California MUTCD, and so it is an allowed treatment. One thing to consider is parking. You can see in this picture that the bicyclist is traveling in the opposite direction of those parked cars. So you do want to consider the door zone, but in this case, you're on the passenger side, so there's going to be less of the opening on that side. And then you're also making eye contact with the people in the car. So actually could be considered better than the non-contraflow bike lane. And then another innovative treatment is left side bike lanes. And these are great when you've got a one-way street or else a street with a median on it. You can also put them up against the median. And it's really great for separating the bicycle and bicycle and bus conflict. If there's a lot of bus stops and frequent bus stops, that interaction between bicyclists and buses pulling over creates the leapfrog effect, where you pass the bus when it stopped, the bus passes you after it leaves it, and that continues all the way down the road. So this just removes that situation by putting the bikes on the left. It's also good if there's not parking on the left side, and you do have parking on the right side, so you just move the bikes to the other side of the street, eliminates that conflict. And then also near interchanges, it's somewhat useful. If you've got high-speed entrances onto freeways, then you can just remove the bikes from that movement. So it's easiest on one-way streets, but we have seen it implemented on two-way with the median, or adding just basically a center-running bike lane. Another one we're seeing more and more now is the buffered bike lane, and that's where you add a striped buffer space between the bike lane and the travel lane, or else between the bike lane and the parking lane, or both. So on the parking side, that it continues to help eliminate the door zone issue, and on the other side, it just provides some extra comfort, especially when you've got higher speed traffic. The other big benefit of this is if you have a bunch of extra width, say you're taking away a vehicle lane, and you want to stay away from adding that greater than 8-foot bike lane, then you can stripe out a buffer, and it's pretty obvious that that's not a lane that vehicles should be traveling down. Our recommendations for this are the combined width of buffer and bike lane should be a minimum of 6.5 feet, and the buffer itself should be a minimum of 18 inches. Once you get beyond 2 feet, you want to start adding the diagonal stripes that you see here to really make sure that's understood to be a buffer. And it's both diagonals or chevron markings can be used. With the wider buffers, you want to use chevrons, and that goes towards bikes and cars are going the same direction. So the chevron indicates that vehicles will be traveling in both directions. And then you can see the width here. Again, there's the extra width from the door zone. In this picture, it's not hatched out, and there's not, say, a second line defining that door zone. So if you really want to make sure that cars don't park away from the curb and keep them over there, then an additional stripe is good to include. All right, so now getting into the really innovative stuff. One-way cycle tracks, or also known as protected bikeways, are when you actually have some sort of physical separation between vehicles and the bike facility. So this goes beyond just a painted buffer and actually becomes something physical. The buffer space can be these pop-up delineators, movable planters, raised curb. Parking is often placed between the cycle track and the travel lane, a landscape buffer, and I'll show you some examples of these. And really this is taking it beyond just, again, trying to get those interested but concerned riders out. And this is a great way to do it because it really eliminates any sort of vehicle and bicycle conflict, except at driveways and intersections, which we'll get into. Again, here's some examples of landscape buffer, movable planters, and then floating parking down there. So there's a lot of design criteria around these. For the bike lane, 5-foot minimum, 7-foot preferred, and really the larger is preferred because essentially the bikes have no room to pass each other. So if a bicyclist comes up on a slower moving bike, then they're also physically prevented from passing that bicyclist. So wider is good, especially in higher bicycle volume areas. Driveway areas should be marked and signed. The buffer space, 3-foot minimum, 4-foot preferred width, and that's often the case with when you've got the parking to the left. So you don't want to create a door zone issue to the left side of the bike now by creating these cycle tracks. So this gives enough room to open the door, load groceries, put the stroller away, that sort of thing with the 4-foot buffer. And then there's some recommendations for the markers. Street sweeper and snowplow issues. Snowplow not so much in the Bay Area, but for sure in Colorado. You're creating a narrow track, and street sweepers were not designed to handle that. So, and that you don't want an accumulation of debris in that cycle track. That actually is bad for cyclists more than others. And so you really need to talk to the jurisdiction's maintenance team and see if they're either willing to get a narrower sweeper, which they've been known to do, or what the minimum width is between, say, a physical object and that curb so that they can come in and sweep that area. And then parking lane, similar to our, in general, 7-foot minimum, 8-foot preferred. One thing to consider is that if you're shrinking the travel lane, if you have one travel lane right against a parking lane now, an 11-foot travel lane, say, up against 7-foot parking is not going to be a very comfortable place for people to open their doors. So 8-foot parking is preferred there. And that also allows a little wiggle room so that they stay out of the buffer area as well. And here's the dimensions shown for that we discussed. Conflict at driveways. So that is an issue. You're now placing the bicyclists behind the parked cars, so cars turning into the driveway, their vision could be blocked of that. So we do want to consider the sight triangle as you approach the intersection. 10-foot sight triangle at driveways is what we recommend, 20-foot sight triangle at minor street crossings, and that's in the NACTO guidelines. So the other line of thinking, though, behind this is that if you do have a fair amount of separation there, so vehicles are actually able to make the turn almost fully before crossing the cycle track. So they have better alignment than they would with a bike lane right next to them. Essentially, they're looking towards their right instead of all the way over their shoulder to see if there's a bike coming. So by tightening that up, it actually can slow the vehicles down, making that turn, and provide better sight lines between the bicyclist and the vehicle. So there's some trade-off there, and so consideration should be given to both. Also, making sure that markings are provided across there to make sure that vehicles coming out of the driveway know that they're crossing a cycle track and look for bicyclists. In this example, they've got large bicycle stencils there. Also, this is a great place to put in the green skip striping to really highlight that, and even some directional arrows to show that which way the bicyclist will be coming. Did want to mention raised one-way cycle tracks. These are often at the same level or maybe slightly below the sidewalk level, but then that brings them above the roadway level. Just to further differentiate it, and then the vertical separation becomes part of your buffer space and your physical separation. In this example, they actually kept the existing curb line along there and then just built out from that. And then the other thing to keep in mind with raised cycle tracks is the pedestrian bicycle separation. If it looks like sidewalk and is built like sidewalk, then pedestrians are likely to wander onto it. And one of the points of the cycle track is to make sure you keep that separate. In this case, it's actually a good example of how they use the furniture space. So you've got trees, bike racks, really as a physical barrier separating the two. And then you've got different pavement treatment. So in this case, it's a stamped concrete to help differentiate that as well. In this example, the buffer there is a little tighter than we'd want. You can see that if that van opens their door, they're probably sticking into the bike lane. So still good practice to have at least that 3-foot buffer there. And then you can also have a mountable curb there, and there's some guidelines for that. So the natural transition from one-way is to two-way cycle tracks. These get more complicated because now you have bicyclists traveling both directions where cars don't necessarily expect bicycles to be traveling both directions. But they're good on one-way streets, so it acts almost like the contraflow lane does. And then it's also appropriate on where you have limited interruptions. So say you're along a waterfront and you don't have intersections coming across there, then that's a great place for a two-way cycle track. And then at larger intersections, there's special consideration for intersection treatments with two-way facilities because of the additional conflicts you have with opposing bicycles and vehicles. So Charlie will talk more about that, but where you have that additional space it's usually more appropriate. Some of the benefits of them are you don't have to have a buffer. Say you had one-way cycle tracks on both sides of the street, that means you're doubling up on that buffer, it's taking up more width. So when you don't have that width, you just need one buffer in this case. It's also alleviates some of that passing issue because basically you could have a broken yellow line so bicyclists could pass each other when it's safe. So for width considerations, it can help with that. And again, some criteria on this: 8 feet minimum, 12-foot preferred width. Again, dashed yellow center line to separate directions. Driveway treatments are especially important with these. Maybe some additional signage that reminds drivers to look both ways when they're crossing it. Parking lane similar to the parking lane and buffer lane are similar to one-way cycle track. Although the sight triangles are a little more of a concern because you need to consider left-turning vehicles off of the main street with bicycles coming the same direction as them. It's just not a common movement for cars to consider when they're turning into locations. So you want to consider expanding your sight triangles and making sure that's all accommodated, especially if you at unsignalized locations where you can't separate it through special phasing. So that's the wrap up of the corridors. Now we're going to get into the more difficult part, the intersections.
Okay, thanks, Ryan. So I'll take us probably through the next 15 minutes or so and then wrap up with Q&A. I'm going to talk through various intersection treatments, the first being intersection crossing markings. So there's really a lot of different allowable treatments you can use for intersection crossing markings. In general, what we're trying to do with these is increase bicyclist visibility and clarify bicyclist right-of-way and positioning through the intersection. This is a few different ways of doing it. All of these are allowable. The one on the top left is one from Chicago, where they're using the green-colored pavement through that conflict zone. On the outside, they're using what we call elephant's feet. So that's the white skip stripe, but it's kind of a big, blockier, more square striping pattern than the typical skip striping that we see. It's actually a 1 foot by 1 foot square. You can see the bike stencils oriented towards the drivers as they're entering and exiting the minor street. And then in the center, you can actually see the skip stripe double yellow. All of the devices on this one are allowable. On the right is actually that same example that Ryan showed earlier of the contraflow bike lane, except showing the sharrows through the intersection to delineate where the bicyclists should position themselves, and also to make it a little bit more clear to motorists as they're driving across this intersection that they should be expecting bicyclists to be going in the contraflow direction, especially as over the years they probably got used to cars coming from just one direction here. Having that paint on the through the intersection makes it a little easier to remind them to look both ways. A couple others, people in San Francisco are probably familiar with the Wiggle, which is, I think it goes, between Market Street and Golden Gate Park. It's a way of getting between the two without going over any hills and while staying on relatively quiet streets. There they use the greenback sharrows through the intersection. This is mostly to clarify bike route choice, not necessarily bicyclist positioning within the intersection. And then on the right side is a two-way cycle track crossing at a traffic signal. It's actually separate from the pedestrian crossing. You can see the crosswalk on the left side. And then in the bike crossing, they're using the green-colored pavement and the elephant's feet again. So a lot of different techniques. It really just depends on your situation and your jurisdiction and how comfortable they are with one device over another or one type of maintenance cost over another as to what device they may pick. The next device is called using shared lane markings in exclusive turn lanes. So this is something that we would typically define as innovative, and it's also allowable. Oftentimes, this is something that we'll use when there isn't sufficient width for both a standard bike lane and a right turn lane. Kind of the absolute minimum, if you're going to have both a standard bike lane and a right turn lane, is 14 feet. In that case, it might be preferred to use both a 5-foot bike lane and a 9-foot right turn lane. That really depends on your vehicle fleet that you have making that right turn. If you have a lot of trucks that are doing that, 14 feet might not be enough for them to make that right turn and stay within their lane. But if you're mostly passenger vehicles, that might work okay. And really the idea here is that the bicyclist kind of stays to the left side of the right turn pocket, and that's kind of naturally where they want to be aligned to get into the bike lane on the far side of the intersection. And also makes it so they don't have to mix with vehicles in the through travel lane, which are usually going at a higher rate of speed as they go through the intersection. So the one on the right, this is the example of the shared lane markings in the exclusive turn lanes. That's allowable. I've heard that there is a lot of what we see on the bottom, the combined bike lane turn lane, where they actually use the dash striping within the right turn pocket. That's something that was officially disallowed by FHWA, so it's not something that we recommend anymore, but it is something that is in the NACTO Urban Bikeway Design Guide. Ryan and I have been talking a lot about the green colored pavement, so I want to talk a little bit about our recommended practice for how that's used. So there's actually been research done on this that shows that marking conflict zones with green paint is an effective way of getting drivers to yield. They're more likely to yield when they're diverging across that conflict zone versus when they're merging. However, green paint is expensive to maintain and it wears off really quickly. So what we usually say is that what makes the most sense is to use it where you most need it in the conflict zones. And there's also a law of diminishing returns on this. So if you mark all the bike lanes green, people kind of tune that out and stop paying attention to it. So we really encourage people to use it where they most need it. It's important to caution that green pavement itself doesn't make up for poor intersection design. So we're always encouraging jurisdictions to kind of make the harder decisions that involve designs that really slow drivers and naturally clarify the bicyclist right of way. This example is kind of our recommended use of skip green in conflict zones, where you can see in the various conflict zones where vehicles would be expected to either merge or diverge through the bike lane, we use the skip stripe, versus areas where bicyclists have exclusive use of that space, we use the solid green. So that's kind of how Ryan and I are typically trying to design green bike lanes when we're doing so. Bike boxes, this is an innovative device subject to experimentation. The intended use of bike boxes is to reduce the risk of right hook collisions. So this is a collision where a bicyclist in the bike lane against the curb is traveling through and a vehicle turns right across their path. And they can be very serious collisions. People can get very seriously injured, and there have been fatalities because of right hook collisions. So there's a lot of hope that these devices will help reduce those. They can also help bicyclists with left turns when the bike box is actually positioned across the left turn lane. And they also provide bicyclist queuing space. So if you have high bicyclist volumes and they're all kind of stacked up waiting at the red light, the bike box can provide them a little bit more space to stack. Some of the basic design criteria in these, at least 10 feet deep, that's enough space for bicyclists to kind of ride into it and kind of rotate their bike a little bit and align themselves for when the light turns green. They always have the stop lines for drivers in advance of the bike box. No right turn on red is something that's required with these in NACTO. There's a shall statement in there with those. So whenever we're planning these, we want to make sure that we're evaluating the trade-off of prohibiting that right turn on red when we do our operations analysis. And then it's always important to make sure bicyclists can actually be detected from the bike box. So whatever your bike detection scheme is, making sure that that works for bicyclists in the box as well. The green color itself is actually optional. Ryan and I have both heard mixed feedback on these. I've heard that they're good for bicyclists at the start of green in terms of reducing those right hook collision occasions. However, when bicyclists are entering or arriving on green, the vehicles still aren't necessarily looking in the bike box or looking over their shoulder for bikes. So I'm actually pretty interested to see if this is something that ends up getting approved in the MUTCD or not. I'm really not sure at this point based on the research that I've seen to date. Two-stage turn cue boxes are another innovative device subject to experimentation. These facilitate a movement that we call the Dutch left turn. And the way that this works, as I can kind of describe it here in the picture, is that bicyclists enter the two-stage box during the major street through green phase. So here that would be the phase that the streetcar goes on. And during that green phase, they rotate their bikes and then wait for the minor street to get its through green. And when the minor street gets their green, bicyclists can proceed straight, essentially, and make their left turn in 2 stages. At locations where they don't have these installed currently, a lot of bicyclists will use pedestrian push buttons at the crosswalks to make this movement. So really, the two-stage turn cue box just formalizes that movement and provides more space for that movement to occur in a more predictable way. Some of the basic design criteria on these: minimum depth of 6 feet, which is basically just enough space for a bicyclist to stop and rotate and fit entirely within the box. The bike stencil and turn arrow are used to make it clear that that's a space where bicyclists are supposed to use for turning. If it's positioned in front of a right turn lane, then no right turn on red is required. So again, there's some operational trade-off there that may need to be evaluated. And then again, bike detection is important. The green color is optional in this case as well. Bike signal heads are something that we've been seeing for a long time in California. That's actually kind of the rare occurrence now where California, at least on traffic control design, is ahead of the curve. Everywhere else, these have interim approval from FHWA. They basically consist of red, yellow, and green bike indication signal heads, and they're really useful when you're connecting a shared use path into an intersection, or when you're connecting a cycle track through an intersection where you need to have exclusive phases to keep the bicyclist protected from turning vehicles. Some of the key interim approval requirements from FHWA is that you can only use these when there's no simultaneous conflicting vehicle movement. So that includes permitted right and left turns. They don't want to give a mixed signal to bicyclists that, you know, they have a green bike and that they're not going to have conflicting traffic. So you can only use it when there's no conflicting vehicle movement. FHWA does not require any warrants to install these. They really say if it's necessary for safety and to eliminate conflicting movements, you can do it. That's a major difference from the California MUTCD, which has a pretty high warrant for installing these. And for that reason, I'm pretty interested to see whether or not we eventually change that in California and drop that warrant similar to the way that they have in FHWA's interim approval. And then the accompanying sign just helps bicyclists understand that they're supposed to follow the bike signal. Bike detection itself isn't actually a traffic control device, and there's many different ways of doing it, some of which are traditional, some of which are innovative. One way or another, it's just important that if we're providing traffic signals, that bicyclists actually be able to get all the way through them. There's a lot of different ways that you can achieve that, either with the inductive loops in the pavement, which is what we're showing here in the photo. Camera detection has been around for a long time, and some of the kind of emerging technologies include things like radar and LiDAR, as well as thermal imaging. If there's any rules on these, it's really just that they need to be intuitive. There's been research out there that's shown that the stencils alone are really not well understood. The signs that accompany the stencils, like we have shown on the top right, help with that understanding. But if it's not really intuitive that a bike needs to stand in exactly the right spot, they're probably not going to get it. And I generally find, for that reason, that I prefer some of the kind of less location-specific devices. So cameras and radar, LiDAR, thermal, those are all better at sensing bicyclists in a general area versus having them lined up exactly on top of the loop. And then different technologies may be promising in the future in having an ability to actually differentiate between bicyclists and vehicles, or even bicyclists and motorcycles. And that can be really useful if you want to provide certain special timings for bikes, like if you want to provide more green time when a bicyclist shows up versus when a motorcycle shows up, to make sure the bike can clear the intersection before the other street goes. Mixing zones are kind of, in many cases, considered the weak link of cycle track design. These are allowable treatments. They usually just combine various treatments that are already allowed. And basically what happens here is that the cycle track approaches the intersection, and you need to provide some space for vehicles to turn across the path of the cycle track, and for that reason they create a mixing zone. So on the bottom right, you can see an example from New York City where the cycle track actually kind of ends and you have sharrows through the turn lane. The cab is actually right on top of it here, but you can see in the CAD drawing on top of it that there's actually some yield lines there. So the intention is that the drivers yield at that line for bicyclists that are entering the pocket. And then in DC on the left, you can see an example where they actually use the combined bike lane turn lane. So this would be an example of a treatment that's technically disallowed by the MUTCD now. But the intention here is that bicyclists can occupy that bike lane and vehicles are to yield right away to them when they merge across that bike lane at the intersection. The general rule of thumb that I've heard in the industry is that mixing zones can maintain a reasonably high level of user comfort when you have less than 60 turning vehicles per hour. So pretty simple rule of thumb, 1 vehicle per minute, anything above that, and you really need to start looking at exclusive phases to maintain the same level of user comfort through the intersection. Okay, closing it out with the protected intersection. This is something that's gotten a lot of buzz over the past year. This is an intersection design that's actually modeled after Dutch intersection design for cycle tracks approaching intersections. Some key features of a protected intersection that make it protected. There's these little kind of football-shaped corner refuge islands that place the bicycle stop bar well ahead of the vehicle stop bar at the intersection. And that way, vehicles, when they're turning right, they can see the bicyclists well ahead of them as they're preparing to make their turn. It actually sets back the bicycle crossing approximately 1 vehicle length from the adjacent travel lane. And what that does, as Ryan alluded to earlier, is it really means that the vehicles approach the bike crossing at 90 degrees and they have a much clearer plane of vision and much better sight triangle versus bike lanes where they kind of drivers have to look over their shoulder to see bikes currently. Also allows free bicyclist right turns from one-way cycle track on a one-way cycle track. And then it's a pretty easy maneuver for bicyclists to make a 2-stage left turn on the protected intersection. This is something that I wrote a pretty extensive wiki post on a while ago. Turn conflicts are kind of the one thing that we're unsure about as we're planning and designing these. What we've generally found based on Dutch design guidance and my conversations with a few consultants in the Netherlands is that they generally allow one-way cycle tracks to run concurrently with vehicle right turns from a shared through right turn lane when you have up to 150 turning vehicles per hour. So that's kind of the upper limit of right turns to have a protected intersection with a shared with a shared through right turn lane. Once you get over 150 turning vehicles per hour, that's when they would provide a dedicated right turn lane with a protected turn phase. Or if they already have, in some cases, you already have the dedicated right turn lane, they would also provide a protected phase there, even if they didn't have 150 turning vehicles per hour. Dutch design guidance typically does not allow conflicting left or right turns to operate concurrently with a two-way cycle track. And then there's a few different options for how these are operated. One is that you give bicyclists a lead bicyclist interval at the beginning of the through phase so that they can establish themselves in traffic before the right turning vehicles possibly go. And then another way of doing it is with what they call an all bike phase. That's not currently allowable in the United States. We call that a bike scramble, but it's something that has worked pretty well in the Netherlands for a long time. Dave Stanek just wrote a really great paper on this that he presented at Western ITE, and that is actually, I think, on its way to going to TRB, that compares some of the delay implications of the different ways of operating a protected intersection. So I won't go through all of these in detail, but basically what this is doing is looking at a standard intersection and then 4 options on the right for the protected intersection, one with right turn yielding, one with the leading bike interval, one with scrambled phases, and one with protected right turns. And the lesson here is that there is a capacity trade-off depending on how you operate these. for vehicles and delay trade-off for all users. So I think, if anything, that paper is definitely worth a read if you're talking to jurisdictions about this, and just making sure that if you're planning facilities like this, that you're evaluating the operational trade-offs and that they're going to be willing to make those. I think I'm really optimistic that we'll see some good safety research on these and know whether or not they actually provide the optimistic safety results that we're expecting. But that'll be something for the years to come. So that's it for content today. Before we dive into Q&A, I did want to just point out that we have 2 other future webinars for the BikePed201 series this year. The second will be Design Standards and Guidance for Pedestrian Facilities. Ryan and I will be teaching that one. We're still picking a time. We were originally going to do that at the same time as this webinar, but figured it would take way too much time, so we're going to split that up. And then the other one is Corridor Planning. If you haven't had enough of me already, I'll be teaching that one with Jeremy Klopp in September, and that one's already on the calendar, so feel free to add it to your Outlook, and look forward to having everyone at both of those as well. With that, we have about 11 minutes scheduled for questions. Hopefully, Ryan has the answers to all the questions. If not, I'm really good at Googling things, so I'll keep that open. And yeah, if anyone wants to start off and dive in, please do so. You can also type them into the chat box.
This is Ellen in Walnut Creek. I'm curious, the advisory bike lanes, has there been much research or tracking so far on driver understanding of, and safety and collisions, the driver's understanding that they can veer across the dashed line to avoid a head-on collision? I mean, obviously they would, but I mean, you're potentially putting 2 drivers in opposing lanes without the center line, and it's somewhat unusual. And as always with these innovative things, it's are our drivers understanding what we're doing?
Yeah, I can go first. It's very limited implementation in the U.S. Minneapolis is one place that does have it. I actually don't know about the research on those facilities, but they've installed signage to accompany it that actually defines that they yield to bikes and explains basically what that graphic had shown in terms of who's got right of way and who needs to yield. So I think at this point that's pretty critical. But otherwise, it's similar to other narrow streets without center lines, I think, in terms of understanding that you can't just run into the oncoming traffic.
Right. I mean, I wonder, it seems almost redundant.
Yeah.
Yeah, I don't have anything to add, Ryan, other than that usually FHWA and NACTO are really good about publishing research, or about putting the published research for the different experimental devices on their websites. So Ellen, I can dig into that a little bit and see whether or not that research has been published yet, and if that does address the driver understanding issue that you pointed out. Okay, it looks like Ron put a question into the chat box. Any thoughts about how to best match different bike treatments with land use context place types? Sorry, hanging sentence. Similar to the Smart Mobility Framework recommendations. I think in general, how would I address this question? I guess I've always thought that even independent of what sort of infrastructure we provide, there's going to be some distance barrier to bicycling. I know we constantly cite that, so many trips are less than 1 mile or less than 2 miles, so they're easily achievable by bike. But certainly different land use contexts and place types are going to have different convenience, almost comparisons from driving to biking. So I almost tend to think that in the locations where biking can be most convenient as compared to driving, when you consider the full kind of time cost of your trip from walking to your car, parking and unparking your car, and actually doing the drive. So in kind of more urbanized areas where biking is actually going to be more time competitive because of all those considerations, that we probably want to be providing greater types of comfortable infrastructure because we can expect that distance and time are no longer a barrier. Therefore, the infrastructure itself should be comfortable enough to provide for the for the majority of the population. And there's all sorts of different methodologies we can use to get at that. Ryan, I don't know if you have any other thoughts on that question.
No, I think you got it.
Okay. Thank you. Okay, Kyle asked, I'd like to hear your thoughts about use of sharrows in the middle of travel lanes on streets. Will allowable but low on-street parking. This seems to emphasize riding in space that bicyclists typically wouldn't use. So, Kyle, I think what you're describing here is a situation where on-street parking is allowed but underutilized. So bicyclists would typically ride against the curb. So should we put the sharrows in the travel lanes, in the center of the travel lanes, even though it might seem counterintuitive to bicyclists when there's no cars parked on street? Ryan, what do you think of that?
It's definitely something that we've done a lot of in terms of putting the sharrows still centered in the lane, especially on designated bicycle boulevards. And actually the thing that goes along with that is we've, in some cases, recommended edge lines to go along with that. And that kind of is twofold. One, it encourages the bicyclists to not ride in line with where parked cars might be. And then also when cars aren't parked there, it gives a little added benefit in terms of traffic calming and making the roadway feel narrower when you have that edge line stripe. The downside of both of those things are that an edge line stripe can look like a bike lane when there's no cars parked in it. So then you may be actually encouraging bicyclists to be riding in that lane. And our sharrow is enough to bring them out of there. Where I've kind of landed is bicyclists are going to ride near the edge of the road when there's space, but we still want to make it clear that this is a designated bicycle boulevard, and that when there are cars parked there, it's up to vehicles to allow those bikes to come out of that parking lane and take the full lane.
Yeah, totally agree with all of that, Ryan. Patrick gave us an image of the signage they're using for the advisory bike lanes. It looks like this one is from Hanover, New Hampshire. So there's the one that they're using. Any other questions out there?
This is Jamie in Orange County. I was curious about the shared bicycle turn lane where the dash line is no longer allowed. And you had shown the example in DC where it also had the green paint. I'm wondering if the green paint could still be applied even though the dash cannot be there to delineate the edge of that zone.
Yeah, so the specific approval status on green colored pavement is that it's allowable within existing marked bike lanes. So anywhere you have a bike lane, you can use it. And it's experimental when used as a backing for sharrows. So those are kind of the official rules on the green paint. I believe that so what that means as it applies to like the combined bike lane turn lane is that I think what FHWA would have concluded is that the combined bike lane turn lane is disallowed because you're basically not providing the dedicated space for bicyclists in here. And that's what the intention of a bike lane is. So that's why they want you to use the sharrow in that space instead. So I don't think that adding the green to the bike lane would, or to the conflict zone here, would make it allowable. I think if you wanted to do a design similar to this that combines the green with a sharrow in a turn lane, it would probably look like, let me find the example that Ryan had. Whoops. It would look like this example here from Denver where they use the greenback sharrows. This is actually intended for through bicycle travel, even though it's in a left turn pocket. This is basically a very basic mixing zone within a left side cycle track on 15th Street. Does that make sense, Jamie?
That does. Thank you.
Yeah, sure. think I saw a question from Mike out there somewhere. Come on in. Mike asks, what are the recommended treatments for left-turning bikes into cycle tracks, bike boxes, or left-turn bike lanes? Ooh, Ryan, what do you think of this one?
Yeah, turning movements in and out of cycle tracks are pretty tricky, actually. The complete intersection addresses that, or the protected intersection, excuse me, does help address that with the two-stage left turn and really simplifying that. If you can provide it, then the two-stage left turn box is really the best way to handle that, because it's really the natural way that bicyclists will travel along the cycle track and then exit essentially into that left turn cue box. Where we haven't had parking between the cycle track and the travel lane, we've provided openings so that cyclists can exit and enter into the left turn pocket, which only works when you don't have parking and also is difficult to clearly communicate with cyclists. So that's not necessarily the best solution either. Two-stage left turn boxes, when you can fit them in, is the best way to go, in my opinion.
Yeah, I think the only thing I'd add to that, Ryan, is that typically whenever we're looking at intersection connections to cycle tracks, and Mike has been through this with me before, where I kind of sit down and draw all the movements to and from the cycle track in all directions and figure, what phase is this going to operate with, how exactly are bicyclists going to make this movement, and sometimes it ends up kind of being a blended set of treatments where it has to be. So I hate to say that maybe I can't quite stick with one certain device, but often it's kind of many different treatments combined.
Yeah, and I would just add also that the difficulty at signalized intersections is you do want to make sure that you can detect the bikes that want to turn often onto the cycle track. And so to do that and to make sure that you detect them when they want to make that movement, you've got to have some sort of dedicated space, whether that's moving them over to the left turn lane or a bike box, or putting them in a two-stage left turn cue box.
Great. Okay, we've got about 2 minutes left. No questions in the chat box. Any more questions over the phone?
This is such a download. This is Ellen again. Such a download of information. It's been awesome. And I can't remember everything, so I have to ask, are there any approvals from FHWA or Caltrans that we're anxiously awaiting that aren't yet approved for full standard use? I don't think I heard of any. There's the one that's been recently disallowed.
I think one of the most interesting things coming up will be to see what kind of standards and guidance the Caltrans actually develops for what they're calling the Class 4 bicycle facility, the cycle track. They just had a summit, I want to say 2 months ago, where they brought a lot of local jurisdictions, some consultants together, and basically said, tell us what you want us to do with this, because you guys have actually implemented this and we don't have any experience with it. It's unclear where that will go from here, but they're mandated to actually come up with design standards. So I think that'll be pretty interesting to have that come out, because that'll, again, fall into the standards category instead of just the guidance.
The only other thing I'd probably add to that, Ryan, is California specifically. I'm interested to see how the California MUTCD does or does not change its language pertaining to bike signals now that those have FHWA interim approval. And the FHWA interim approval in terms of placement and appropriate placement, rather, of bike signals is very, very different than the California MUTCD. So I'm just not sure really who's going to trump who when they release the next version of the California MUTCD in the future. Otherwise, the challenge to all this is just that the status of all these devices, they could get interim approval any day, and it's really, really hard to know whether or not they're going to and when that's going to happen. So, I guess I'd just go back and encourage everybody to be checking this website, and then Caltrans has their own website that clarifies the status of various FHWA interim approvals in California. So that's another resource you can be looking to as well.
Charlie, this is Justin in Seattle. I'm just wondering, do we have a spot for this sort of information on the wiki, on the BikePed wiki page? It seems like that might also be a good place to have that. Whether it's, you know, keeping updated with what's approved or disallowed, or even just having some links.
Yeah, I think that's, you know, as I guess my role as discipline group leader is to keep our wiki space clean and functional, and I can certainly strive to get all of these resources kind of consolidated. I know our wiki space especially, perhaps over an abundance of enthusiasm, is full of a lot of design and planning manuals that might be a little outdated. So at the very least, this presentation will be recorded and available in PDF form, and we can try to get all of the kind of most pertinent information key as well. Okay, not seeing any other questions. We're 2 minutes after 1 o'clock Pacific, so I'm going to go ahead and say that the webinar is closed. Thanks everybody for coming today. Really appreciate your participation. Feel free to email Ryan or I offline with any questions you have. We really look forward to engaging you in your future projects, and enjoy your Tuesday. Thanks a lot.